Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about the idea of null space. But before we go into that idea, let's talk about the solution of homogeneous system first. So what is a homogeneous system? A homogeneous system looks like this. You have matrix A and you have unknown variables here, x, and it is equal to 0. So that is the idea of homogeneous linear system. So if you want to visualize, it looks like this. We have a matrix A. A here is m by n, 1 to mth row, 1 to nth row. So here is m by n matrix A, and then here we have x. So x here represents all the unknown things, unknown variables, constants that you would like to find the value. So here we have, of course, if this is m by n, therefore this must be n by 1 matrix. So we have 1, 2, up to nth row. So here is n times 1 matrix, and the result here is going to be m by 1. So here is the result of m by 1. Here is all the results, and all the values here have to be equal to 0. So this is unknown, and these are the values that you would like to find out. And if you find out all the values here, we call it solutions. And if you want to be more specific, you can say that these are the solutions of the homogeneous linear system. And in particular, the solutions here will be given a name, so they just call it n. So you can call that n. N is the set of all these solutions, and n here is known as the subspace of the vector space known as Rn. So here is dealing with real number, and here we have n dimension. So the result that we have here, n here, has something to do with the idea of null space. So here is the definition of null space. Let's say you have a matrix A. It is m by n matrix. So the null space of A, so you're talking about null space of this matrix, is the subspace of Rn consisting of solutions of the homogeneous linear system of this. So basically what we have here is actually the solutions of n, which you have seen in this slide. Okay, so once you have managed to get the solutions to this unknown, where the unknown variables here come from the system, homogeneous linear system, then the solutions here is known as the subspace of this vector space, and the solution here is also will define the idea of null space of matrix A. So it is denoted as null space of matrix A. So this is the solution obtained from the homogeneous system of linear equation. So that's the idea, and we are going to look at some simple example here. So first of all, here is matrix A, and here is the system of linear equations, homogeneous, because here we have vector 0. And the question is asking you to find first the column space of A and then the null space of A. So we're going to start off with finding the column space of A. And as I've mentioned in the previous video, the idea of column space is quite easy really. We are talking about the space that is spanned by columns of matrix A. That means we have this first column, second column, and third column. Therefore, we're talking about the space that is spanned by that. So here we write down all of the columns one by one, okay? So this is the answer to the first question. Next, what is the null space of A? And as defined here, in order to find the null space of A, I need to obtain the solutions of the homogeneous linear system, and then what we can do is we can then state that this is the null space of A. Okay, so now let's consider the linear system. Here we have A x vector 0. So here we have, well, the matrix 1 0 0 1 3 negative 1. And here we have clearly this is a 2 by 3 matrix. So here is a 2 by 3 matrix, therefore here must be 3 by 1. So we know that we have 1 2 3. So we have 3 unknowns that we need to find, and of course this is a 2 by 1. The result is 2 by 1, so we have 1 0 and second 0. So this is 2 by 1 matrix. So that is our starting point. Next, we can do the usual process. We can consider the augmented matrix. So here we have 1 0 0 1 3 negative 1. Here we have 0 and 0. Okay. Well, clearly I don't think we need to do anything much because it looks quite simple already. Yeah. So what we can do is we can see that from the first line here, well, we have basically 0x1 plus 1x2 minus 1x3 is equal to 0. Therefore, x2 is equal to x3. So that is the first part that we get. Okay. Now next is well, we have this part here which can be translated as, well, x1. I'm just going to write it straightforward. So 1 times x1 is just x1 plus, well, 0 x2 is gone. So here we have 3 x3 is equal to 0. Therefore, x1 is equal to negative 3 x3. So that is the second equation. So we have like 2 equations but 3 unknowns. Therefore, in your mind, you should be thinking that we are going to be dealing with a free variable, and I'm going to let x3 to be the free variable. Yeah, so let x3 equals to t. So t is any real number, can be any real number. Therefore, x2 is going to be equal to x3, which is equal to t as well, and x1 is negative 3x3, which is equal to negative 3t. So that is the solution for x1, x2, and x3. Next, what I can do is, well, let us try and write the solution in terms of this notation. So here we have, so therefore x1, x2, x3 is equal to, well, here is negative 3t, x2 is 3t, x3 is also t. This is the answer that we've got. Now what we can do is we can try to consider separating numbers and alphabets. And how can we do that? Well, you can see that we have t in each part here, so we can consider taking out t and just focusing on numbers right inside here. So -3, 1 and 1. So you can see t times -3 is -3t, t times 1 you got t back, t times 1 you got t. So based on that, you can say that thus the null space of A, which is null A really, is the value of this vector here, so -3, 1 and 1. So that is the solution for the question asked here. Okay, I think we can do another example, for example this one, just to make sure that everybody here is comfortable with the idea of null space. So here is another matrix, matrix A, and you are asked to find the null space of A. So to find the null space of A, the starting point has to be by considering the homogeneous system of linear equations. So we have A times with x, the unknown variables, must be equal to 0. So here our matrix A is, well, God, this is such a big matrix, so just be patient with it. -2, -3, -5, 1, 1, 4, 5, -3, -1, -3, -4, 2. So here is a, well, 4 by 4 matrix. Therefore, here must be 4 by 1. So we know that we have x1, x2, x3, x4. So we have 4 unknowns. And so since we have 4 by 4 with 4 by 1, the result here is going to be 4 by 1. So 4 by 1. So here's 0, 0, 0, 0. So that is our starting point. And as always, we can solve for this by considering the augmented matrix. So here we have 1, -2, 1, -1, 2, -3, 4, -3, 3, -5, 5, -4, -1, 1, -3, 2. Well, here we have 0, 0, 0, 0. Okay, so what I'm going to do now is I'm just going to transform all these values here into 0. Okay, so all the values here will be turned into 0. Therefore, I need to consider, first of all, for this one here, second row plus -2, the first row. So the result that I get here is going to be, well, 2 times plus -2 is 0, -3 plus 4 is 1, 4 minus 2 is 2, -3 plus 2, this is -1, this is going to be 0. Next, for this part here, R3, we're going to do on the same stage, R3 plus -3 R1. So 3 minus 3 is 0, -5 plus 6 is 1, 5 minus 3, 2, -4 plus 3, -1. And here is going to be 0. Finally, this part here has to be turned into 0 as well. So we have the fourth row plus the first row. So -1 plus 1 is 0, 1 minus 2, -1, -3 plus 1 is -2, 2 minus 1 is 1. So these are the results that I got. Well, next what I can do is I would like to consider turning this value into 0. So what I have to do is, well, I need to consider R3 plus -1 R2. So we have 1, -2, 1, -1, 0. And then we have 0, 1, 2, -1. Okay. So here we have 0 minus 0, 1 minus 1, 0, 2 minus 2 is 0, -1 plus 1 is 0. So everything here is going to be, well, 0. Also, I need to consider turning this into 0 as well. So that can be achieved if I consider the fourth row plus the second row. So here we have fourth row plus the second row. So based on that, you can see -1 plus 1, 0. Of course, 0 because 0, 0. -2 plus 2 is 0. 1 minus 1 is 0. So at the bottom here, everything is also 0. Now, this is the simplest form, and based on that, we're going to consider the line here first. So basically it says that we have 0 times x1 plus 1 times x2 plus 2 times x3 plus -1 times x4 is equal to 0. Well, therefore, this is 0. So x2 plus 2x3 minus x4 is 0. Well, x2 is just x4 minus 2x3. So that is the first equation that we have. Next, we have this to consider. So here we have, I'm just going to write down straight away. So it is x1 minus 2x2 plus x3 minus x4 is equal to 0. So here is x1 is equal to 2x2 minus x3 plus x4. So that is another equation. So overall we have two equations, but you can see we have four unknowns. So two equations, four unknowns. Therefore, two must be free variables. And we are going to let the free variables be x3 and x4. So I'm going to call let x4 be equal to t. T is any real number, and x3 is equal to something else, s, and s is also any real number. Therefore, these are the two free variables that we have. So based on that, if we consider this part, we know that x2 is equal to x4 minus 2x3, which means t minus 2s. So that's the value of x2. And if you consider this equation here, we have x1 is equal to 2. The value of x2 is t minus 2s minus x3. x3 is s plus x4. x4 is equal to t. Hang on, I need a plug for my laptop. Alright, now you can simplify the result here to be, well, we have 2t minus 4s minus s plus t, and that can be simplified as 3t minus 5s. Okay, right, so I'm just going to erase this part here. Okay. So now based on the solutions that we have already obtained, I can write down in this way. We have x1, x2, x3 and x4, and the solutions are given as, well, for x1 this is the solution, 3t minus 5s, x2 is t minus 2s, x3 is s, x4 is t. Now this matrix here, you can write it in terms of everything related to t and everything related to s. So it's a combination of t and s. So what it means is we can write it down in terms of 3t plus, so here is negative 5s. So when you have 3t plus negative 5s, you will get the result as 3t minus 5s, right? And similarly, for this part here, it will be t plus negative 2s. Okay, so when you add the components here, you will get the result t minus 2s. For this one s, that means there is no t, that means here is 0 plus s. For this one t, so here we have t plus 0, so there is no component of s, so here is 0. And again, we can try and write the result here such that we only have numbers in that particular matrix here. So what we can do is we can take t out of this matrix. So if we take t out, you will be having the value of 3, 1, 0, 1. And you can see clearly that when you have t times 3, you will get 3t. T times 1, you get t. T times 0, you get 0. T times 1, you get t. So that's the idea. And similarly, you can do the same for this part here. So we take out s, and here we have negative 5, negative 2, 1, and 0. Therefore, the null space of matrix A is equal to this factor, these two matrix here. Okay, so we have 3, 1, 0, 1, and then we have negative 5, negative 2, 1, and 0. So that's the answer. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.